Welcome back to this video series, Accelerating AI with Continuous Delivery. Now, in this part, what we'll be doing is we will be checking out the code which we've used in our previous video, and we will be running it locally and also explaining the parts of the code as well. So before we get started, there's some tooling that we need. So what we need is Python 3 installed on our local machine, and we also need the Python package manager as well. We need to have Docker or Docker engine, Git and Git LFS, and optionally an AWS account and their CLI tooling installed. Now, all the links for this are available down below this video. And of course, we'll also need some sort of code editor. Now, I recommend Visual Studio Code or Sublime or anything similar, but if you already have one, feel free to use that one instead. Now, let's get started by checking out the code itself. The repository that we will be using is located in the description down below, so make sure you open it up. Now, the commands that we will be running inside this tutorial are available in the setup part of the documentation inside the repository itself. But before proceeding, what we will be doing is forking this repository into our own account. So let's go to the top and click on the fork button. Now make sure you also uncheck this part over here. So we want to copy all of the branches into our account. Now click on create fork and the repository will be copied into your own account. Now the next step is to actually check out this code to your local machine. Now you can go into the code part and just copy this to the clipboard. Now you just need to proceed to your terminal and paste in this command. And the repository will get cloned to your local account. So let's proceed to the next steps now, setting up the project itself. Now we need to go into the directory that we've just checked out. So using the cd command and the directory name, we can jump into the directory itself. And now we need to switch the branch to initial. Now this is the branch where we're starting from scratch. So it's really important to do this step. Now that we've switched to the initial branch, what you need to do is actually activate the Python environment. So let's paste this command over here, and this environment will then get automatically set up. Now we also need to activate it. So let's use this command to activate the environment, and you can see this over here means that we've successfully activated the virtual environment. Now we just need to install the packages as well. So this is this command pip install. And it takes some time to install all of these packages, but no worries. Once this is done, we will be proceeding to the next step, and that's downloading the dataset. Now, the final step is to download the dataset itself, and you can do that by using this command over here. So this is this command in the documentation. And once you trigger this, it will get downloaded. It's a big file, so give it a few seconds to go through. The next steps that we will be doing is we will be opening up this code locally and running the commands to prepare our model. Now, the final step is to download the dataset itself, and you can do that by using this command over here. So this is this command in the documentation. And once you trigger this, it will get downloaded. It's a big file, so give it a few seconds to go through. The next steps that we will be doing is we will be opening up this code locally and running the commands to prepare our model. If you open up this folder in any code editor, you should see the following structure. So data folder, metrics folder, models folder, and source folder. In the source folder, all of the source code is located, and in the data folder, you should have your images file that you've just downloaded. Now, let's run the scripts to actually extract these images into our data folder and also prepare the model itself. So let's open up the terminal. Okay, now let's extract the images that we have. So this is a command called prepare, and it's a script, and let's run it up. And you can see that the images were decompressed into our folder. And these are the images of the cats and dogs that we need for training our model. So the next thing that we need to do is actually train our model. There's a script called train inside this directory as well. So let's run it up. Once we run this script, it will take some time to train your model. So we're going to fast forward this to the end, and we'll continue with the next steps. In the end, what you get is how well your model training is doing. You can see how much images we've used for training and how many images we've used for validation. And you can also see how successful your model is. Now, this is pretty useful information. Now, the next thing that we also need to do is test if everything works out. Now, there's a script called test, which basically runs tests on your model. And if everything is okay, it exits out nicely like this. Now, once our model is trained, we can go into our code editor, open up the metrics tab, and inside here, you will be able to see the images that are the result of our model training. So you'll be able to see the confusion matrix, how your results are doing, and what are your top losses. Now, these images get automatically generated each time you train your model. Inside the models folder, your model gets created once the script is done running. So these two files get created over here. Now, what we'll do is we'll open up the app locally to see how it looks like. And later on, we'll check how the code looks like for these scripts and explain it all. Now, to run it, we use the command streamlit run, and we just need to specify where it's located. When we run this, our app will open up and we can see what's the final app. We've already trained our models, so we can upload an image over here. So let's go and upload an image of a cat, and we can just click on, is it a cat or a dog? And you will get the end results. Now you can see that the model predicted correctly that this is an image of a cat. Now let's do a deep dive into all of the scripts that we will run right now and explain the code itself. Now the app.py file is our main application file. So inside here we have the code that runs that server that we've shown earlier. So what we do in this part is we basically load our model first, and these are the models that are generated by our model training script. So they're located inside the models directory over here. We need to load them up first. And then we just set up the title of the app, that the name is Cats and Dogs Classifier. And this is basically the final functionality. So here we add the uploader of images. So we have supported types PNG and JPEG. And what we do is we open up our image, and then in the end, we also add the predict button. So over here, what happens is we import the make prediction thing, which kind of predicts if this is the cat or dog. And in the end, we basically write out based on the probability. So if it is a cat, we write out the certainty of that probability. So it's a really simple script, and you can do these with Streamlit, and it's super easy to set up. So again, make sure to check out their documentation. Now, the prepare script is the script that basically just unzips the images that we've downloaded. Now you can see that these are the images that we've downloaded, and here we just open up the file and basically extract all of the contents. So these are the images over here that we've already shown earlier, and it's a really simple script. So the important one is actually the training script, so train.py. This is where all of the code is actually located. So this is the code that basically trains our model, and it's comprised of a few steps. So let's explain these. So first, what we need to do is actually load the model itself. And this is a really super important piece of code. What we do over here is we basically set the number 0.2. Now, what is this number? If you remember from our videos, we split our dataset into two parts. Now, this is the part that is used for validation, and this is the 20% that we were talking about. The label function is the one that tells us if an image is a picture of a dog or a cat. Now, that's the part where we actually check if the file name is uppercase or lowercase. And this one is located in the utils directory. So you can see that this is just a file name, and it checks if the first string is uppercase or not. And this basically tells us if it is a cat file or not. And basically the final part over here is the optimization part. Now, we've said that we can resize our images. If we resize our images, it takes less time to process them. And this is an optimal size where we still get valid results. Now, the next part is fine-tuning the model itself. Now, this is done in this piece of code over here. So in this piece of code, we actually load this data loader that we've set up over here, and we add the ResNet 34 base model to it. And this is basically it. And then we just export our model files. So once we create this, we just export them and save them. And this is basically our final result. Now, later on, we can basically just print out the images. So, those images that we've shown, and we can save them inside the metrics directory. And this piece of code is located over here. So plot.save. In the next part, we also save a classification report file. So this is basically used for having the end results in a file that you can upload anywhere. The next step is also showing the confusion matrix. So this is the code that basically creates the confusion matrix itself, and we also save it inside the metrics directory. And the next part basically plots our top losses, and this also gets saved into a file. Now this is all the code that it had on the Kaggle platform as well, but in this case what we're doing is we are saving the images locally. So the results get saved inside our metrics directory. Now we can use these results later on to publish them anywhere we want to. And this is all the code that is useful for the training of our model. Now make sure you play around with it and run it and check it out. So what's up next in our video series? Now in the next part we'll be checking out a tool called DVC, which is short for data version control. And with this tool, what we're able to do is we are able to track different data sets and also reuse different versions of our data throughout the training that we are doing. So make sure you subscribe to our channel, and I'll see you in the next video.